Today's lesson is 6-8, Scale Drawings. The main idea of this lesson is solving problems involving scale drawings. So a scale drawing is going to be a picture of something that's either much smaller than it actually is, or much bigger than it actually is. So something that would be much smaller than it actually is might be, say, a map, or maybe a blueprint. Those are kind of just an outline of what, say, a room or a house or maybe a porch would be like. Scale model is the same thing, but it's a model. Like you would think a scale model, if you've ever heard of model cars or model airplanes, they're little cars that are much smaller than an actual car. Scale is going to be a ratio of distance to actual distance. So it's kind of a ratio. For example, on a map you usually see a little key that says 1 centimeter is 20 miles. So they have a scale on there to tell you that if you're going to something a couple centimeters away, you know it's going to be 60 miles away, for example. And lastly, scale factor is the scale in simplest form, written as a ratio. So ratio of scale in simplest form. And again, simplest form is either done using division or the L method. That's what should come to mind when we're talking about simplest form. Example 1, what is the actual distance between Hagerstown and Annapolis? Now we could typically take out a measuring device to measure between these two distances, but we are given right here that it's supposed to be 4 centimeters. We also have the key right here. So first I'm writing down 4 centimeters. But we also have a key right there that 1 centimeter is 24 miles. And right now I'm writing 1 centimeter on the bottom because my 4 centimeters on top. I'll put 1 on the bottom because that is a whole number. And then we'll write 25 mi for miles on top. My labels of centimeters are going to cancel out, which is why I wrote it on bottom. So now I have 4 times 24, which we would use a calculator to find out that that is 96 miles. And that is our answer. That's the work you're expected to be shown. There's not a lot to it for that problem. On to our next one. Find the actual distance between each pair of cities. We're missing a word here. Round to the nearest tenth if necessary. So, Chicago and Cary, Illinois. So both towns in Illinois, the map distance is 3.25 centimeters, and our scale is 1 centimeter is equal to 15 miles. So you got to write up here 3.25 centimeters over 1 times centimeter, we know are on bottom, to miles. We got to keep track of our labels because sometimes they'll mix it up with us. So 1 centimeter is 15 miles. Now, we'll have to open up our calculator here quick. And we need to do 3.25 times 15. And I get 48.75. Again, our centimeters will cancel first here. But we have 48.75 miles over 1. So we'll write this as just 48.75 miles. Our next, we'll actually fill that in our blank here since we have a table. Our next one is Rochester and Byron, Minnesota. Map distance is 1.25 centimeters, and 1 centimeter equals 6 miles. So we're going to have to extend our page a little bit for more space. So we have 1.25 centimeters over 1 multiplied, not equal to, by our ratio they gave us here is 1 centimeter over 6 miles. 6 miles on top. So 6 miles over 1 centimeter. We're going to cancel our centimeters, so we're just going to end up with miles. And now we have 6 times 1.25. Again, using our calculator, we have 6 times 1.25 to get us 7.5. So 7.5 miles over 1 equals 7.5 miles. Third, we have Minneapolis, Minnesota, and Green Bay, Wisconsin are approximately 8.7 centimeters away, and 1 centimeter in this case is 50 miles. So we're going to write that down here. We have 8.7 centimeters over 1 times, I already know we're going to have centimeters on bottom, and it's 1 centimeter for 50 miles. Cross out centimeters on each one. So now I have 8.7 times 50. Do the math here on our calculator. I got 435. So we've got 435 miles over 1, which is 435. Now I will leave the last one for you to fill in for number 4. Orlando and Miami, Florida, we have 11.3 centimeters, and 1 centimeter equals 75 miles. Just remember that centimeters do need to cancel, and then 75 will be on top. On to our next one, our scale drawings. We're trying to find the scale factor of each scale drawing or model. Now if we go back to our first page, we're going to remember that scale factor is the ratio of the scale in simplest form. So they're telling us 1 inch equals 4 feet, but we don't know how many inches we have. So that is what our ruler is here for. I'm going to measure the train here. My measurement gets me about right there. So I'm going to round off and say that that is 7 1/4 inch. So I have 7 1/4 inch times 1 inch equals 4 feet. So we can't multiply 7 1/4 times 4 because we can't multiply mixed numbers. We need them to be in a proper fraction form first. And to do that, we do 4 times 7, denominator times the whole number. It's going to give us 28, and we add 28 to the numerator. So our 1 becomes 29/4. 1 plus 8, 28 is 29. Now we can multiply by 4 over 1. And also, we will also cross off our inches, so we already know our only label left is going to be feet. 29/4 times 4 over 1, and I see that we can cancel. Remember rules of multiplication, we can cancel on top as long as we can also cancel on bottom. I divided both the top and bottom by 4, and now I'm left with 29, and our label is feet. The last one here is the grasshopper. So we're going to measure it from tail, and then we're going to measure all the way to right there is the antenna. Try to do a straight line, but it's right around 8.5. So I'm going to call that 8.5. And actually we're dealing with centimeters, so we're going to change that 8.5 because we're dealing with the inch side. For centimeters, we are looking at, actually we were looking at centimeters. It's 85 centimeters. 8.5 centimeters. I was looking at millimeters. I think we got it straight. Right there on there is 8.5. Yep, sounds good. So 8.5 times, underneath the ruler is 1 centimeter per 15 millimeters. So we can cross out our centimeters, or our final answer will be in millimeters, and I have 8.5 times 15. Again, we'll bring up our calculator, and I get 127.5. So I'm kind of running out of space, so I'll write it down here, 127.5, and our only label left is millimeters. Since it is over 1, we can just leave it at that, and that'll be our final answer. So that is our final example for this section. Again, feel free to refer to the other sections on Moodle for peer tutors and examples that can also be done for you.